Okay, so in this video, we're going to do trigonometric derivatives. So the derivatives of trig functions. Okay, so we're going to do derivatives. We're going to start doing derivatives of trig functions because we're only going to do derivatives of two of them. Okay, and that is the derivative of sine, the derivative of sine of x, and the derivative of cosine of x. Remember, ddx is just another notation for the derivative of with respect to x. Okay? Okay, so before we go, there is one differentiation rule I may have forgotten to mention. Okay, and that's this. The derivative of a constant times any function f of x equals the constant times the derivative of f of x. Okay? So if you have a constant multiple, that's why it's called constant multiple rule sometimes. Okay? So if you're multiplying a function by a constant, you can pull it out of the derivative. Okay? So it's basically the constant multiplied by the entire derivative expression. So it's a pretty important rule. Okay? It's very helpful. You can use it a lot. Okay? So what we're going to do is find out the derivatives of sine and cosine. So the derivative of sine of x equals cosine of x, and the derivative of cosine of x equals negative sine of x. You can prove these using the limit definition. Won't do them now, might do them later though. Okay? So what we're going to do is we're going to apply some of these derivatives. Okay? So let's start applying some of these derivatives. So let's have a function f of x equals sine of x. What is the tangent line to the graph of f at pi over 3 comma root 3 over 2? Pi over 3 comma root 3 over 2. Okay, so let's first find the derivative. The derivative of sine of x. And that is just cosine of x. Okay, just a direct application of the rule. Okay, so if we want to find f prime of pi over 3, f prime of pi over 3 is cosine of pi over 3, which is 1/2. Okay, 1/2. So what we can do is you can write in point-slope form y minus y1 root 3 over 2, which equals m times x minus x1. So we got y minus root 3 over 2 equals 1/2 x minus pi over 6. So we can write the equation as y equals 1/2 x plus root 3 over 2 minus pi over 6, or y equals 1/2 x plus 3 root 3 minus pi over 6. And that is our tangent line. Okay? So let's do another one. We're going to find more tangent line graphs. okay? Because that's literally the only application we have right now. There are more applications, but for now, we're going to have to do tangent lines. Okay, so what we're going to do now is, well, there is one application, one clever one. We're going to find all the points, on the interval 0 to 2 pi such that well, not such that, but where f of x has a horizontal tangent. Horizontal tangent line. So we're going to find all the functions from 0 to 2 pi, all the points which have a horizontal tangent. So here, maybe. So we're going to find all of the points where that happens. And our function will be f of x equals root 3x plus 2 cosine of x. 2 cosine of x. So let's find f prime of x. Well, f prime of x will just be square root of 3, use the power rule, okay? Plus, nice where that constant multiple rule comes in. You can pull out the 2, and the derivative cosine of x is negative sine of x. So in reality, it should be a minus sign. I have a minus sign over here, and it's minus 2 sine of x. Now, we want to find all the x coordinates first, where the graph has a horizontal tangent. So the slope of a horizontal tangent line, well, what's the slope of a horizontal line? Well, the slope of any horizontal line will be 0. So we want to find the x coordinates such that the derivative is equal to 0. Okay? So what we can do is root 3 minus 2 sine of x equals 0. Okay? We can bring 2 sine of x and add it to both sides, equals root 3, and you get sine of x equals root 3 over 2, and x equals pi over 3, as well as 4 pi over 3. So pi over 3 and 4 pi over 3 will be, not 4 pi over 3. 2 pi over 3. That's what I meant to say. Pi over 3 and 2 pi over 3. Okay? So we solved the equation for 2. So we want to find the points. So let's find f of pi over 3. F of pi over 3 is equal to root 3 pi over 3 plus 2 cosine of pi over 3. Cosine of pi over 3 will be 1/2. So that's just 1. Okay, so that is 2 times 1/2 is 1. Okay. And we can rewrite this as 3 plus root 3 pi over 3. F of 2 pi over 3 equals 2 root 3 pi over 3 plus the cosine of 2 times the cosine of 2 pi over 3. So the cosine of 2 pi over 3 is negative 1/2. Think unit circle, okay? 2 pi over 3 makes the cosine negative, okay? It's greater than pi over 2. So cosine of 2 pi over 3 will be negative 1/2. So it'll be minus 1. Or that will be 2 root 3 pi minus 3 over 3. Okay, so we get pi over 3, 3 plus root 3 pi, all that over 3, and 2 pi over 3, comma, 2 root 3 pi minus 3 over 3.